Hey, welcome to the 24th lesson on C++. During this lesson, we will learn how to work with template classes in the C++ programming language. In the previous lesson, we already covered the topic of template functions. Template functions allow you to pass an additional data type, along with parameters, into the function, and this type is used within the function. When we talk about template classes, the concept is similar, but it is applied not to functions but to the entire class. In this lesson, let's practically explore how templates can be used in practice. At the beginning, let's create a class without using templates. I suggest creating a class that will work with arrays. In this class, I'll have a couple of fields where we will store the length of the array, and there will be a pointer where I'll store the entire array. At the moment, these two fields will have empty values, and later, in the constructor, we will set them. Now let's create the public access modifier and define the constructor. In this constructor, I will pass an array of pointers and the length of the array that I will work with later. Inside the constructor, let's write the following. I'll set the value in the len field to the one I received from the user. Additionally, we need to allocate memory for our pointer ARR. We allocate memory for the array, and the length of this array is set to the data entered by the user. Now we only need to do one more thing. We need to set all the values for the array used within the class. That is, I create a loop that will go from 0 to the length of the array, incrementing the variable each time. Essentially, inside the loop, all that will happen is that we will access our pointer ARR, perform offsetting each time, and set the value as what we get from the user. We receive the array A from the user, and here we also perform offsetting. Also, immediately, we need to write a destructor. The thing is, I performed memory allocation. And I'll remind you that when working with dynamic memory, you always need to perform memory cleanup. Therefore, if I wrote the word new, I always need to write delete. It makes logical sense to write memory cleanup in the destructor. That is, at the moment when we stop working with an object of this class. So, I simply call delete, then specify square brackets, and say that I am clearing such an array as ARR. Here, you can also write another method. Let's name this method get, and the purpose of this method will be to display all elements on the screen. And here will be roughly the same code as in the constructor. The only difference is that here I need to work only with our array. We simply output each element on the screen here. Also, at the end of the loop, let's add a new line character. Now let's create a new array in the main function and give it a name. Let's assign some values to it. Now, I simply create an object based on the array's class. Let this object be named object1, and let's pass data to it inside the constructor. As data, I'll pass the array and the length of this array. Since our array has 3 elements, I write the number 3 as the parameter. Now, additionally, I will access this object and call the get method to display all the information about all the elements of the array. If you run this, you'll notice that all the array elements are correctly displayed on the screen. We have essentially created a class for working with arrays. You can create objects, and then you can easily work with the elements of this array, display them on the screen, and perform other manipulations. Now let's consider another situation. Let's imagine that we have another array, and this time it will have a data type of float. Let's also change the integers to floats in our second array. And now, if I create a new object and try to pass our new array, an error will occur. And this is quite logical because in the constructor, we only accept the integer data type, and now we are trying to pass a data type such as float. And now, to get out of this situation, we can specify that our arrays class will be a template class. To do this, we need to use the template keyword before the class, then open angle brackets, and write the class keyword along with the name for our parameter. As you can see, the same syntax was used in template functions, only there we wrote the word type name inside the angle brackets, and here we use class. Now I can use this data type everywhere. Let me use this data type for our pointer, and also in the constructor, I will use this data type. I will do the same for memory allocation. Essentially, we don't need to use it anywhere else. Now we return to the main function and can do the following. We put angle brackets and specify the data type we are passing. In the first case, I will pass the data type integer, and in the second case, I will pass the data type float. Now, we can run the program and make sure that it works correctly, displaying elements from both the first and the second arrays. In this way, we have implemented a template class. Template classes are very similar to template functions, allowing us to accept a certain data type along with some parameters. Well, that concludes our lesson. In this lesson, we created a class for working with arrays and made this class a template. I hope you enjoyed the lesson, and if so, don't forget to subscribe to the channel to not miss new videos. See you soon, bye.